Hello, everyone. B flat here. Um, been thinking about some things regarding refraction, standard atmospheric refraction, and a collection of points I think that individuals have brought up over the last several weeks. Methodology of trying to come up with answers. One of those being reaching out to Google or AI for the response. This document will have my input in red. The yellow that you see here on this first page was the question I asked. The black is the response, and I've taken and added commentary below each one. So thought it'd be kind of interesting to just kind of go through this and talk about it. Make sure individuals understand kind of where my thought process is in the research. So, I asked Google the following question, and AI responded. Is standard atmospheric refraction in effect 24/7 every day across all kinds of atmospheric conditions? This was an identical question that Pablo's dog asked, and Bobby Shafto had an exchange with FE peer review about the process of asking AI for answers and their concerns. So Bobby Shafto and FE peer review commented this week about their concerns regarding asking AI for information. I also agree that one should question sources that AI draws from. I believe that the information that I'm analyzing and commenting in red has been backed up by multiple sources along with AI, even from the literature that was recommended by FE peer review years ago, and that it supports my view. There's a wealth of information out there to learn from. The most trustworthy information comes from those who don't have a dog in the globe versus flat earth debate / fight. Okay, and I'm kind of going off script right here, is that people have dogs in fights and opinions and everything else, and it just like spins out of everywhere and goes in whatever direction someone would like to lead you to believe. And when you go there, you have interesting things to deal with. FE peer review has his pack of dogs that he encourages to deal with those who question the globe refraction narrative. I've seen this in his commentary on Bobby Shafto's videos. He and I have gone rounds. The individuals tend to show up to ridicule. And the ridicule that they bring should never be equated as intelligence. What do they fear? Can you bring an intelligent response to a conversation that has scientific backing or scientific reasoning? I mean, reasoning is probably the biggest thing here. Is can you rationalize a thought process that is acceptable for the accepted, to work with the accepted science? And, they fall well short as far as I'm concerned. If someone wants to contest that for anything that I have posted on my sites or commented on, more than happy to explain why it's contested. I'll defend that 24/7. If anyone is out there that is willing to engage their brain cells on a thought process, I'd be happy to have a conversation with them. Unfortunately, I deal with the dogs in the pack that are out there just to try to make you look like an idiot. So we will continue. AI brought up that atmospheric refraction is a continuous phenomena that occurs 24/7, as light must pass through layers of air with varying densities whenever it enters or travels through the atmosphere. However, standard atmospheric refraction is a mathematical model based on average conditions, and actual refraction is rarely standard. I agree with that statement. First off, light has to be passing through layers with different densities. Very important point right there. If light is not entering into a medium of a changing density, it's not refracting. Think about that. I'm going to be bringing that up multiple times. If the IOR, the index of optical refraction, is not changing along the path of light, then it is not refracting. Science agrees with that. Okay, the people who are going to contest this, well, they got a problem with real science. So to continue, the degree of refraction is highly dynamic and depends on the specific temperature, pressure, humidity profiles of the atmosphere at any given moment. Definitely agree with that. Okay, this is real physics. So what I wrote here, and maybe I'm being redundant, but let me just read it because it is what it is. Standard atmospheric refraction has always been researched and developed for celestial or aeronautical functional use. Okay, celestial. Astronomers viewing light that originates above our atmosphere. Or aeronautical, things that are very high in our atmosphere that still need to be communicated with. Okay, so the functional use of some of the light, that deals with communication or observational relevance. Okay, both of these are going through a majority of the vertical column of our atmosphere. Okay, that's important. Again, there is change along the lapse rate, the vertical path directly above us. A lapse rate is the vertical rate of change for that which is moving along the zenith. Straight up and down. What changes along that path? So in earlier centuries, it had been the astronomers and mathematicians heading up this research. As they looked into the celestials and tried to figure out why they don't behave exactly and anal retentively as they should in a mathematical equation. And refraction is definitely a reason why. Light can change its path when it's moving downward through a changing IOR. The vacuum of space, or what is above our atmosphere, is classified as 1.00000 IOR. Near the surface of the ocean, I believe it's 1.00003 roughly. There's a change. May seem insignificant. As far as calculations on refraction, it's significant enough. There's different ways of looking at it, but there's a definitive change. So in modern days, communicational connections and observations with man-made objects at great altitude has warranted more research, with both parties, communications, aeronautical, and astronomers. A significant vertical column of air is of relevance. I just said that. Okay? Across the vertical column, the IOR, again, that is the index of optical refractive density. It changes significantly with elevational change. Very important. Understand up and down. Horizontal or side to side, you don't have that same change. So this is not the same for terrestrial observations, where a very low percentage of the total air column is relevant. The change in IOR based on vertical travel is minimal compared to the distance of horizontal travel of light rays. So refraction only happens when light progresses into a medium of different index of optical refraction. Understand refraction, people. Okay, you have to have a change in the values. You go into Walter Bislin, or anybody who conveys this, talks about a density change. A density change is a change in the index of optical refraction density, the value of the IOR. If there is only one change along the path, that path will refract at a single angle. This is what Snell's law is all about. Now, the community that defends my target, we'll get to that eventually, will say Snell's law is irrelevant because light is continuously progressing into a denser medium and it will progressively refract. I'm really not going to agree with that. Or I'm really not going to disagree with that. Okay, it really makes sense. But the only path it really makes sense on is one that is angling downward or upward through our vertically orientated atmosphere. So, if light continues to progress into a medium that, again, progressively changes in IOR, it does not alternate and change, it just doesn't change into something different than the previous and then wander a path. If it enters a single change, it refracts at an angle, it goes straight. It has to progressively change in IOR to continue to refract in a direction. Okay, if it can continually progress into a changing IOR, the light will continually to refract again and again until there is no longer a change in the IOR. So again, to progressively refract in only one direction, upward or downward, and I hate that term, but the medium will have to progressively change in IOR into either a denser or a less dense medium. Not both. Medium with alternating IOR along the path of light travel will result in refraction both upward and downward on the changes along the path. Okay, this can be a net zigzag path, horizontal zigzag path, up and down, up and down, up and down, based on our atmosphere, which is very dynamic. So this is why terrestrial refraction is never standard. It will rarely, if ever, continuously refract in only one direction. it should never be considered to be legitimately represented as an arc with a radius. I'll do a final rant on that arc with a radius at the end. So AI came up with a number one point, the concept of standard refraction. Standard refraction is an idealized value. Idealized. Not measured, it's just idealized. It's represented for use in general calculation, such as those found in nautical tables or basic sunrise-sunset predictions. Okay, I'm going to summarize this one when we're done with this point. So standard values, many calculations assume a standard refraction angle at the horizon of 34 arc minutes. Okay, you're kind of limiting yourself here. So in the standard conditions, these models are typically based on a standard atmospheric pressure of 101.325 kilopascals and a temperature of 15 degrees Celsius. Limitations. Using a single standard value does not account for meteorological differences between locations or sensors, such as the difference between Hawaii in July and Alaska in January. Great. So we have an idealized calculation based on a very specific angle of a standardized condition that is never the same across our world. And all of the above points are specific to celestial/aeronautical observations, even when one references the horizon. If you talk about an object that is just above the horizon and yet you're still looking at a celestial object, it is still, the light is coming from above our atmosphere and progressing down through that full column. So remember this, all celestial objects are above the total vertical column of our atmosphere. So then AI continued. Factors causing 24/7 variability. While refraction is always occurring, its strength and direction fluctuate based on the following variables. Okay? AI is bringing this to me. Don't disagree with it. It's in countless textbooks, that I've read. So, variations. Temperature. Lower temperature increases the refraction angle. Refraction increases by approximately 1% for every 3 degrees Celsius decrease in temperature. Okay. I think I'll touch base on this in point number 3. Pressure. Higher atmospheric pressure increases the refraction angle, increases by approximately 1% for every 0.9 kilopascals increase in pressure. Humidity increases the refraction angle in warm, humid summer months. Refraction can also significantly be stronger and more variable than in cool, dry winter months. The altitude zenith angle, refraction is most extreme for objects near the horizon. Low altitude, because light must travel through a longer path of denser air. For objects directly overhead at the zenith, refraction is 0. Okay, so once again, AI's response is pulled from celestial or aeronautical position of research, where light is still traveling across a complete vertical column of atmosphere. For this to apply near horizontal terrestrial refraction, one would have to show changes to these variables can can regularly exist across horizontal paths. So if a person is standing at the edge of a shore, edge of a lake, body of water, and there's someone standing 10, 15 miles away on the opposite shore. They're both at the same elevation. They're both at the same pressure. The atmosphere should be close to the same humidity. And they should be close to the very same temperature unless there's a cold front moving in. So one should assume that both of these individuals are experiencing or existing in a near identical atmosphere or a value, an IOR value, that is near the same. So how can there be a denser atmosphere between A to B and then denser from B to A? We have laser paths, reciprocal, both directions. And the narrative is that a laser is going to follow a curvature because it's bending into a denser atmosphere. Okay, but if from A to B it's being projected into a denser atmosphere, then from B to A it's being projected along a less denser path. And yet we have observational recordings from people that both sides are seeing the laser. Okay, now think about the geometric implications to that. There is a sagitta. There should be an earth bulge in between. Okay, the curved path of the laser is supposed to duct over the curvature. But if it's due to refraction, the conditions are not there. They're clearly not there. And all you have to do is rationalize that in your own mind. And I'm not going to sell this to the individuals who regularly respond in negativity and bring their ridicule and everything else. I'm not going to. They're not the people who I'm out to influence. Okay, they've made up their mind of who they are and who they want to be, and well, judge them accordingly when you decide if you want to listen to them or not. So, point 3 is the diurnal and seasonal changes. Our atmosphere is very dynamic. We have warmer trendings in our summer and cooling off in the winter. Daily. Let me read it. Refraction follows daily and seasonal cycles due to changing atmospheric structures. A daily variation. Refraction is typically at its minimum in the afternoon when the air near the ground is heated and more uniform. It is often more severe when temperature gradients are strong, such as during sunrise and sunset. What does this mean? Well, you go from a cooling in the night to a sunrise where the sun starts to warm the surface of the earth. That heat then starts to rise up through the atmosphere, and when the sun has progressed away from us, the cooling air settles down back to the ground. I don't think anybody's going to argue that too much. But we can be surprised. There are those individuals out there. But it's a daily variation. Diurnal, happening twice a day. Seasonal, happening based on where the sun is above us, based on the extent of the sun's travel through, Tropic of Cancer, Tropic of Capricorn. Let's not get too much into it, but the sun is either directly above you or further away. Okay, we'll keep that general as a statement. Extreme effects, mirages, and ducting when temperature gradients are intense, such as a layer of hot air trapped near the ground. Extreme refraction can occur. This includes super refraction, where objects normally hidden by the Earth's curvature become visible, and mirages, which can make objects appear lower than they are in the air near the ground, is significantly hotter than the air above. I think I addressed this in the red. Seasonal variation. In northern hemisphere, the refractive index at the Earth's surface typically reaches its maximum in the winter and minimum in the summer. So I agree that the diurnal and seasonal changes are at play every day. I do not agree with the concept of ducting. This would come from a community that you are not allowed to be in unless you share that spherical belief. One should understand refraction first before accepting a narrative from those who have personal or professional bias. Think about it. I mean, if you want to agree with this, you can agree with it. AI is reaching out into the realm of what's published. And again, you don't have to agree with all of it, but this is a great response from AI as far as the discussion point. So, the practical impacts of non-standard refraction. Because the atmosphere is never truly standard, precise predictions for certain phenomena are difficult. Not difficult, mainly impossible. Depending on what you're looking at. If you're looking at celestials, you might be able to draw a conclusion. And again, here we go. Sunrise and sunset. Actual sunrise and sunset times can vary from predicted times by a minute or more because of unpredictable atmospheric conditions. Agree with that. High latitudes. Predictability decreases significantly near the poles, where small variations in refraction can change the time of sunrise or sunset by many minutes due to the shallow angle at which the sun intersects the horizon. I'm not going to disagree with that either. So for navigational caution, again, we're probably talking celestial navigation here. Because refraction is so variable, below 20 degrees above the horizon, sailors generally avoid taking astronomical measurements. Shooting stars below that altitude. Okay, so again, hopefully one can start to have a better understanding as to why standard atmospheric refraction model is incorrect for terrestrial observations that it is being applied to. One should realize that the current method of simulating for refraction, Mick West, Metabunk, Walter Bislin, is based on an assumption of a curved path of light being the norm. If one continues to let others sell this nonsense to you, you will struggle to learn the truth in life. So again, we touch back to, two people standing on opposite shores existing in the same calculatable index of optical refraction. And I'm not saying that refraction can't happen between the two of them. But if you are allowing a program to tell you that there is a ducting effect in which the light is arcing over a supposed geometric model, do you buy that? Well, science and physics tells you how refraction happens. We have individuals that are here solely for the purpose of defending mathematical calculations for idealistic data that support their presupposed view of a geodetic or curved Earth. Yeah, the people who come here and argue with me, I really have identified where they come from. And they don't come from a solid scientific or physics standpoint. These people are arguing for a program that I challenge quite clearly, rationally. And none of these individuals answer my questions with anything that sounds scientific in any capacity. Not based on physics. It's all based on assumption. It's all based on exaggerations. And when you finally get an understanding of it, you can laugh them off, dismiss them, do whatever you want to do. But I have no problem 24/7 defending what I have just gone over here as far as my review of an AI response, addressing the concerns of both Bobby Shafto and FE Peer Review. And if either of the two of them or any of their community wants to put forth anything scientific, I'd really love to hear it, because a horizontal path of light doesn't refract down because the lower little portion of that single light ray is in a slightly denser medium than the top portion of it. I mean, we're not even talking a millimeter for a single light photon or ray, however it exists. The answers that I get from this community are absurd. Absurd. I mean, these people should realize that they're an embarrassment to themselves by bringing it forth. Please, this is an invitation. Bring me something of significant relevance that I can look at and say, yeah, science, physics accepts that. Because clearly at this point, I don't. And I hope there's been people who have stuck with me through this review. There's some other stuff that has been put out or done in the past too. Would love to probably take this and put this into a playlist with some other relevant videos from other individuals. Not that I agree with everything that everybody says, but start putting together a personal understanding of what you agree with or what you don't. I'm not saying I'm 100% right. I will say that I'm putting out what I feel or to the best of my ability I understand to be correct. And I will continue to develop my knowledge based on research, responses, inputs, suggestions, everything else. Doesn't mean I have to accept what anyone says. But I do hear it. I hear it, I judge it, I file it, incorporate it, or not. So, thanks for taking the time to listen to me. Hope this helps.